Okay, so we're looking at creating a pedigree, and most of you did pretty well on this. There were a few people who I think had some confusion about terminology. So it says that the trait being identified and traced is what? Well, no, it says the trait being identified and traced is what? Right on the top. Red eyes. So when you have an affected individual, they are the individuals with the red eyes. Okay? So whatever trace we say, that's what we are tracing, that's the trait that is affected. And I realize that a few of you, I think, just reversed that, and you affected the brown eyes and not the red eyes. So whatever trait we say is this pedigree is tracing, that's what's the affected characteristic. So this is a 3-generation pedigree. It's a fairly simple one. However, there's a trick. You're not all going to end up with the same pedigree. We'll talk about why that is when we get down to the bottom. So we know that we have a maternal and paternal set of grandparents, and that's often a good place to start. And I'll actually move this around a little bit. So this maternal and paternal set of grandparents, we are told, and we'll say that this is dad's, or this is mom's side, this is dad's side. So the maternal grandmother is over here. Okay. So maternal grandmother has brown eyes, maternal grandfather has red eyes. Who gets marked as affected? Yeah, maternal grandfather gets marked as affected. Okay, and we'll just go ahead and finish the maternal side. And you have to read these descriptions carefully. So 3 maternal aunts. That means that your mother has 3 siblings. Okay? And they are all girls. So this is a family of 4 girls, one of whom is your mom. And all 3 maternal aunts have brown eyes. Mom has brown eyes. Nobody there is affected. Okay? No one in that family is affected. On the paternal side, paternal grandmother has red eyes. So on the paternal side, which one of those squares is going to get colored in? The circle. There is the paternal grandmother, and she is affected. Paternal grandfather has brown eyes. 2 paternal aunts have brown eyes. 1 paternal aunt has red eyes. So we have 3 aunts. 1, 2, 3, and we have the dad. So it's another family of 4 siblings. We're going to put the father over here largely for convenience sake because he has to have a line joined up to this mother. And then we have 3 aunts. He's got 3 sisters. So he's the only boy in a family of girls. And we have 1 aunt who has red eyes. It doesn't specify which of the aunts it is. It doesn't say like oldest or youngest or anything else. So it doesn't matter which one of those we color in. We just know that one of his sisters has got red eyes. Now, you have to read this part carefully. 2 brothers have brown eyes. This is all written from your perspective. So it doesn't say, father's sisters, father's brothers. It says paternal aunts. So whose brothers are they? Yours. So we know that there are at least 2 boys in this family, and they both have brown eyes. Now here's the tricky part. If I was doing this worksheet, it would look like this. If Ben is doing this worksheet, whoops. It's going to look like this because it says you. So you should fill that in appropriately for you, whether you are male or female. Okay? So that's building a pedigree. And most of you did pretty well with this. I think a few people got confused and thought that those brothers were uncles. They're not. They're your brothers. So that's easy. Now, what people seem to have a harder time with is interpreting a pedigree. A lot of people missed a lot of these. So let's look at interpreting a pedigree together. Okay, so we have here a 3-generation pedigree. And the first question that we have one more affected female here. The first question that we're asked is this trait dominant or recessive? How many of you say recessive? How many of you say dominant? How many of you disagree? How many of you have no clue and you don't want to commit? Okay. So let me ask you this. Let's look at this affected individual. Were either of her parents affected? No. So if neither of her parents were affected, but they obviously passed on genes for whatever this condition is to her, is it dominant or recessive? It's recessive. So this has got to be a recessive condition. The only time that you can ever have parents who are not affected and an offspring who is if it's a recessive condition. You can have parents who don't have a characteristic and offspring who do. That, by definition, is a recessive condition. Yes, ma'am. Okay, so what makes you believe that's the case? And we just talked about the fact, if it was dominant, every individual who was affected would have to have a parent that was affected with whatever it is. And this could be, red eyes, it could be a widow's peak, it could be some disease. We don't know what it is. 3, this is a trick question. Nobody got this right, not a single person. So again, we are looking at this young lady, this female in the 3rd generation. And the question is, did she get this trait from her mother or her father? It's a recessive condition. She had to get 2 copies of this gene. Who'd she get it from? Both of them. She had to get it from both of them. If she had just gotten a copy of this gene from one of them, she wouldn't be affected. It would not affect her. Okay. And we would say that they would either both or neither be affected because they're identical twins. Remember that we show regular siblings like this. Yeah, okay, I drew it wrong on here. It was right on the paper. They're actually drawn there as if they were non-identical twins. But we show identical twins like this. So they come down off of one stem that splits. So we have identical twins are shown like that, and non-identical twins are shown like that. And of course, non-identical twins can be either same sex or they can be opposite sex. Either is possible. But yeah, those 2 guys are identical twins. So if one of them has 2 copies of that gene, so does the other. And later I'll tell you a very funny story about Mr. Voorhees. Do you all know that Mr. Voorhees is an identical twin? Yeah. And his brother teaches at East Liverpool. I'll tell you a very funny story about Mr. Voorhees that I've heard him tell. Okay, so that's number 4. How can we have offspring in this 3rd generation who are affected when their parents aren't? How is that possible? Nick?
Their parents can be
yeah, exactly. Because it's a recessive condition. We have this idea of carriers. So their parents obviously are carrying genes that aren't affecting them, so their offspring can be affected. And you could also say because it's a recessive condition, because it's a recessive trait, or because their parents must be carriers. Either of those is good. Can you predict the genotype of this affected female? How many of you say, yes, you can? How many of you say, no, I don't think so? How many of you would like to say, well, I'm sure somebody can, but I can't? Okay, that's a fair answer. Well, we said this is a recessive condition, right? So let's say that this is big N and little n. If she's affected, there are three possible genotypes for her. Big N, little n, and little n, little n. If she's affected, which one of those would she have?
Big N.
Recessive, little n. Yeah.
Please excuse this interruption.
Yeah, any one of those affected individuals, we know their genotype automatically. We can look at this pedigree and say, oh, that's your genotype. We've got that. All right. And so that's the answer. So yes, and then the answer, of course, would be little n. Can you answer these questions without knowing what the identified trait is? Yeah, you just did. Sure. We don't have to know if this is a widow's peak, or the ability to curl your tongue up, or cystic fibrosis, or anything else. We can still look at the patterns in the family and apply what we know about genetics to answer these questions. So let's go a little bit further now. Let's talk about a few concepts that we haven't, well, just actually sort of quiz questions. So these are the kind of questions I will give you on a quiz, and your quiz is going to be tomorrow now. It's not going to be today. We're going to finish practicing with this. Okay, so now looking at this individual, can you tell what his genotype is? How many of you say yes? How many of you say yes, but not me? I don't know what it is. How many of you say no, there's no way to tell? Okay. So wait. There are 3 options for any of these people with this trait. We can have big N, we can have big N, and we can have little n, little n. Exactly. We can tell his genotype exactly. 100% guaranteed I can tell you his genotype. You think you know it, Jacob? What is it? Okay. I suspected you might be bluffing. Ben, what do you think? What do you think, Zach? Did you have your hand up, Bailey? Okay, big N, little n, what do you think?
It could be both.
Could it? What do you think?
Big N, big N.
Big N, big N. Okay. So, why do you think it's big N, little n? Or why do you think it's big N, little n?
Because, like you said, you have to have 2 to get,
Bingo. So, this offspring has a little n, little n. Where did she get one of these little n's? From her mama. Where did she get the other little n? From her papa. So, but neither of her parents are affected, which means they both must be carriers.
isn't there a way to mark carriers on this?
There is. We didn't do it on this intentionally. Oh, okay. Yeah, and the question was just asked, isn't there a way to mark carriers? Shouldn't carriers be shown?
Yeah.
Yes. The OGT does. That's the only place I know of that does something like that. Yeah, often. I didn't intentionally because I wanted you guys to go through the process. Sorry. Okay. So, okay. Can we 100% tell the genotype of this grandpa?
No.
How many of you say yes? How many of you say no? Okay. You can't. Here's what we know about those grandparents. We know that at least one of them is a carrier. None of them are affected, so we can rule out any of them having that genotype. We know that at least one of them has to be a carrier. We don't know which one. We don't know if they're both carriers. Either of those is possible. Okay, see you tomorrow and you'll have a quiz box.